gonna fix the AI. So we have a very basic AI, and that AI is not that good. So we're gonna fix it up. So let's open up the script. Oh, yeah. Let's open up the script and let's see what we got.
Oh, which script is this?
This is car AI.
Got it.
Once you get it, delete everything inside because we're not going to be using it anymore. We're going to make our own, a different one. So delete everything inside.
Wait, I already have stuff in here.
Yeah, just delete it. All the stuff we were working on, it was incorrect, and we're not using animations anymore. We're just gonna use our simple, just movement. Okay. It turns out the animation is just the harder way to go. Okay, so your script should look something like this. Okay. Now, what we're gonna do is we're gonna start off with creating our variables. So our first variables the variables that we need is we need to know the paths, the destination or current destination, and how fast we're gonna go. And of course, we also need what number in the path nodes are we in? So are we on the first node, second node? Do we need to keep track of that? Yeah, and then those are the stuff we need for right now. So let's first make our game object, a game object list called paths, because we're gonna look for path. The next thing is what is our current destination? So out of those paths, we're gonna choose a current destination. So vector
Fernando,
3.
can you zoom in, please?
Oh yeah, sorry.
Thanks.
So vector 3 current destination is gonna be empty. Okay. And then how fast is our enemy going to move? Here we're going to say public float speed, and I'm going to give him speed. I'll give him 50 for now. Okay. And finally, we need our current current index and semicolon. Okay, now that we have those four, let's write our start function. So we're going to write void start, and we need to initialize some things. The first thing we need to initialize is our paths. We need to figure out where are our paths. So with every path that we make in our track, we need to tag it as path. So even if you have only one path, that's fine. It's only going to look for things that are tagged as path, and that is a parent of a bunch of nodes. Okay. It's not a parent of path, it's a parent of nodes. So, the little points that you put around the map so the car could follow. So here we're going to say path equals, we're going to do a find. So game object.find game objects with an S, game objects with tag, and we're looking for path. Okay. So that's how you do a search for game objects. Here, make sure you have an S, game objects, so it returns back a list. If you put no S, then it's going to return you only one object, and it's going to give you an error. Okay, so make sure you have the S. Next thing we need to do is we need to choose a random path. So we have this many paths. Depending on how many paths we have, we're going to choose one random path, and that's going to be the path that the car is going to take. So we're going to say random path equals actually, I forgot to create a variable. Yeah, so we have a number from 0 to whatever amount of things are in path. So we need to save it into a variable called random path. So we're gonna go up here, back up here, and we're gonna make another variable int random path. Again, this is just going to keep track of what path did what path did it choose out of all those paths that are available. It's going to choose it randomly. So we say random path.
If you only
equals-
have one path, do you have to do this?
Yeah, you still have to do this.
Okay.
It's part of it. Yeah, it's good practice, anyways. It's scalable. So random dot range, and we're going to start from 0 all the way to path dot length. So depending on how many paths you have, that's the path you choose. Okay. And then finally, once we have that, now we can set a current destination. Our current destination is going to be the first node in our list. So whatever our path is, the first thing on the first child of that path is going to be our first destination. So we're going to say current destination equals paths. We get that random path. And we get the first child. So transform that get child. And we're getting the 0th child. So that means the first child. And dot position. So random path gives you back so path is a game object. We can't grab transform children from there. So we need to grab the transform from that. And then we can get the child. And then the child number we're getting is 0. And we're getting its position. Once we have that, now we need our rigid body and just our rigid body. So let's make a reference up here for a rigid body. We're going to say rigid body 2D, RB. And then down here in the start, we're going to say RB equals get component, rigid body 2D. Okay. Now we have a reference to our rigid body 2D. Now we can start doing moving the car, because now we have access to the rigid body. Okay. Does anyone have any questions? Okay. Now, the next thing we need to do is we're going to make another function. This one is going to be similar to the update, but it's not going to be called update. This one's going to be called fixed update. The reason why we do fixed update is the rigid body runs at a different time. It does a lot of calculation. It doesn't have to do that much calculation, sorry, between frames because it's unnecessary. How the physics engine works in Unity, it doesn't use too much CPU. You can, if you want to, you make it super accurate, but there's no point on being super pixel perfect on a fast pacing or a fast game. There's no point. So you're just making the computer overwork. So instead, they have a function called fixed update that runs every time the physics engine refreshes. So I think for every 6 frames, I think it's every 6 frames, the physics engine refreshes. I have to look that up, but I think it's every 6th frame. So it skips a couple frames. So what we write here is void fixed update. Okay. And inside that fixed update, we're going to figure out how to move our car. Okay. Okay. So how do we know? Are we in where's our destination right now? Let's just say our car is at our start line, and our first node is right in front of us. How do we know that we crossed the line? How do we know we crossed that node and where we're past that node? How can we figure that out?
If you've completed the path once.
Not quite. So let me illustrate it for you. Nothing.
Nothing.
Okay. So imagine this is the car, right? Beautiful car. It still looks horrible. Okay, but imagine this is the car, right? And the car is here's the start line. Okay, and this is node number 1. Okay, this is number 1. Oh, okay, and its position is currently here. Let's just say it's at 0, 0, right? And then this thing is at 10, 0, right? So how do we know that this crossed this node? How can we figure that out?
Well, the position changed from 0 to 10.
Well, yeah, this is slowly going to change. This is slowly going to go forward, right? So let's just say like frame 6, because this is going to update every time the physics engine refreshes. So then it's going to move somewhere around here. Okay. Oh, sorry. My cars are horrible. And then the other frame is gonna go somewhere around here, and then the other frame somewhere around. My cars are getting horrible and horrible. Now they're playing these. Yeah, so this is how the car is gonna look like every time it moves, right? But it's not gonna move downwards. It's just to illustrate it's moving just to the right. So it's not moving downwards. So how do we know we crossed this point? So at this point here, let's just say it's at 2, 0. This and this point here is at 11, 0. So how do we know we crossed it?
I'm not exactly sure. I don't know.
Okay, anyone else?
What was the question?
Okay, so okay, we have our car, right? And our race, and our start line. Let's just say our car right now is at 0, 0. Okay, and our first start point, our number 1, is going to be at 10, 0. Okay, how do we know that our car went through our first point?
On trigger enter.
No, we're not doing triggers.
Collision.
We're not doing collisions either.
We just check if the coordinates of the car equal that.
Yeah, so we actually check. Yeah, we're checking the coordinates if they're close enough. When you're dealing with moving objects, you'll never get a precise unless it's like a super pixelated game where it moves like per pixel. So here we have 0, right? Here we have 10. Now, if the car moves 1 frame later, it's going to be somewhere around here, right? And then this is going to be I said 2, 0, right? So 2, 0, and then it moves again to like 6, 0, and then finally it moves to 11, 0. Oh, my cars are horrible. Go away. Yeah, so if it's 11, 0, right? So here, what's going on is we're checking the x and the x here and the x here, right? So here it's 6 and then 10. It's still not close, but it's it's almost there. But then here we crossed it already. Here we have 10 and here we have 11. But we have to be careful with this. If let's just say we passed it too much, let's just say we're on 20, 20, 0, right? Then that means either our car is going this way or we overshot and we need to go back. So what we're going to do is we're going to have a buffer zone. Okay. So here, if it's, let's just say like maybe 2, so -2 +2, if it's somewhere around that range, so if it's 8 through 12, then we're fine. That means, you passed it. That's fine. You can move on to the next thing. But if you are less than that or greater than that, then you need to, be a little closer. So to do that, we need to find the distance between your object or yourself or the enemy's car, and the current destination. So here we're going to make a variable called float, and this is going to be the distance. We're going to say vector3 dot distance. Okay, and we need to subtract. Sorry, our transform.
Bless you.
Thank you. Transform that position and our current destination. Okay. So again, our current destination is where we're supposed to go, and transform that position is where are we currently. Okay. If that distance between the us distance is less than, let's just say 1, that means we have arrived at our destination, or we're very close to our destination, at least 1 unit away, and we're good to move on to our next one. So our next one, since we're keeping track of our destination with current, with our current index. So all we need to do is just increment current index by 1. So we're going to say current.
Wait, why is this like current destination? For me, it just auto-corrected to current destination.
Yeah, I have current destination. I can
Up
type
there
it
at the top?
Yeah.
Oh, I have current.
Yeah, if you have current, that's fine. It's just I just felt lazy not typing current. Okay, so we have current index, and our index is just gonna add 1. Okay, plus 1. Now here we have a problem, because let's just say we're on our last child. Let's just say there's 10 nodes, and we are on the 10th one. If we add plus 1, we're gonna go to the 11th one, but there is no 11th, so it's gonna give us an error. So what we need to check is if we pass that number, we pass the amount of how many children that transform has, then we need to circle back to 0. So that's going to create the loop. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then it's going to loop back to 1, 2, 3, 4, 5, 6, 7, and then so on and so forth. So it's going to go back to its the beginning. So here we're going to say if current index is greater than or equal to paths random path we chose dot transform dot child count. So how many childs does that path have? If we pass it, then we just set our current index to 0. And then after we increment, we just change the new destination. So we're going to say current destination. Okay. Oh, your destination, and that's going to be our path, random path, whatever path we chose, dot transform dot get child, and we need that new current index, and we grab that position from that current node. Okay. So what's going on here is we look for the path we chose, the random path. We get the child at that location, so we already updated the location, and we're just grabbing the position of that object. So now we have a destination where we're supposed to go. Okay. Once we have this, now the next, let's just say now, let's just say, now we have our new destination.
I think someone just said something, but it was really quiet.
Sorry. Did you make a variable called child count? Because I have a error under it.
Child count? No, it should be. It's a given.
Oh yeah, I just fixed. Never mind.
Oh, okay. Okay, so now we have our if statement. So once we have our new destination, we need to travel to that destination. So here we're going to say else. We're going to start traveling. So how we're gonna figure this out is we're gonna use our rotation. We're not gonna use torque like we did on our card because it doesn't matter. It's the AI. It has to be kind of perfect because that's how AIs are. There is another way. The first way I did it is using torque. So if you use torque, it's gonna have that. It's gonna be like a fish. It's gonna swim left and then swim right, swim left and then swim right. Basically, it's moving left and right, left and right. It can't run in a straight line. Reason why? Because when you're adding torque, you add a little bit to the left and then you offset, and now you're saying, okay, if you're less than this, turn right. Okay, it turns right, and it overshoots, and you do it again and do it again, so you get this kind of fish movement where it's moving left, right, left, right. It can't go on a straight line. So to avoid that, I'm just going to use a kind of a look towards. I have a rotation. Our destination is here. and just keep looking at that destination, and that's what's going to do. So that's what's going to happen. So this is similar to what the turrets did in our tower defense game, and our little enemies that we had on our tower defense. They had a destination, and what they did is just rotate toward looking at that destination. Once a new destination pops up, then it looks to the other one, and so on and so forth. So here we need to do some calculation. So we need to find the difference between the two um, ourselves, or the enemy's position, and where it's supposed to go. So we're gonna call this one T. Uh, call it something else actually. Let's see, vector 3 difference. Current destination. Current destination minus our current position. Okay, so that's going to give us the difference, the vector difference. Once we have the vector difference, then we have to do some geometry. So we have our, if you think of a right triangle, we have our, what is it called? What is it called? The hypotenuse. Oh, flew by. We have the hypotenuse, and then we have one leg of. We have the no, sorry, we have two legs. Because we now have one vector. So we have the x and the y. So what we need to do is we need to find the angle between those two lines. And to do that, we need to use arctangent. Arctangent in order to get our angle back. So here we're going to get our angle. So the angle between those two objects, the current destination and transform that position. So float angle equals math, and we do arctangent squared. Difference. Oops. Hey, come on. Difference dot y and difference dot x. Okay. We have our two components, and then with math, math always uses degrees, so we need to convert this to radians. So radians 2 degrees. Oh, sorry, it uses radians. We have to convert to degrees. So now this is how much degrees we have in an angle. Okay. Once we have that, now we can apply a movement. So unity. That's the weird thing with rotation. So you can't just apply a rotation like movement, because with movement there's x, y, and z. So it's pretty simple. You guys can figure it out. X is the left and right, y is up and down, z is forward and back. With rotation, it's not that simple. There is an extra for each dimension. There's an extra layer. So if you are working in 2D, then you are looking at X, Y, Z. If you're working in 3D, you're looking at X, Y, Z, and W. So you're looking at an extra component, and that component is part of a weird rotation thing. I can't really explain it, but it's you'll learn it in higher math. It's called a quaternion, and a quaternion basically has a W component. So whatever you see on that component is actually a matrix. It's not a regular X, Y, Z. So we need to do some calculation with that to figure out where to rotate, because we don't want the car just to snap to the next location. We want to slowly move from whatever it's rotating, whatever its rotation is, to where it should be. So to calculate this,
I have an error.
Oh, what's up?
Under different, it says the name difference does not exist in the current context.
Difference is like right up here. I just defined it up here.
Oh, mine was just saying T. Did you change it or something?
Yeah.
Oh, I didn't see that. I think you originally put T or something, then changed it to difference.
Okay. Maybe you're just dreaming stuff, thing. Okay.
It was originally T though. I didn't remember.
Was it?
Yeah.
Okay. Well,
I
I
have
don't
an
remember.
error
What's up?
in line 36. Mine says like vector 3 difference equals current destination Minus transform position. I have an error under current destination minus transform position.
You have it as vector 3, right?
Uh-huh.
Put a semicolon.
Yep.
Okay, can you share your screen?
Mm. Okay.
Vector 3 difference. It's interesting. What's the error that it's giving you?
It says that the minus sign is ambiguous or something.
Type 2 vector 2. Oh, we're using vector 2? No. Can you scroll up? What did you define current destination as? Scroll up. Up. Go up.
Oh.
Yeah, you defined it as a vector 2. Has to be vector 3. Yeah. There we go.
Okay.
Yeah. Okay. So back to where we were. So now we need to do a quaternion calculation. So we're going to say quaternion. And what should we call it? R? No. Yeah. No. Rotation. Angle. There you go. Perfect. Rotation angle. And this is going to be quaternion dot angle axis. We're going to grab we're going to make a quaternion from just an angle. So we have our angle, which is angle. And we're going to, one thing we actually have to do is we need to subtract by 90. Reason why, because most of our cars are facing upwards. Sorry. When we make sprites, remember, we always have to make sprites looking to the right. But since this sprites came with a pack, and then we can't really rotate them, unless we do a parent-child thing, but that takes too long. So what we're going to do is just subtract by 90. So all it's going to do is just going to rotate to the left 90 degrees, which is going to be our forward. Again, this is just a small kind of offset. Comma, vector 3 dot vector 3 dot forward. Okay, and then that's going to be our kind of our forward angle. Not our forward angle. It's going to be our what is it called? The axis where it's going to rotate from. So the forward axis, that's where it's going to rotate. If you do another axis or just leave it at default, it's going to have some weird rotation. Again, remember, we're dealing with X, Y, and Z and W. So we need to define exactly where it's going to rotate from. Okay. Now that we have that, we now have the rotation. Now what we need to do is just do a rotate towards. So we can say transform dot rotation. And we're going to do quaternion dot rotate towards. Again, we're not using slurp because slurp is it's fast at the beginning, but then once it tries to get to its destination, it goes really slow. That's not what we want. We want it to be kind of linear. So transform rotation. So that's where we start from. And where do we want to go? We want to go to rotation angle. How fast do we want to go there? Speed, rotation speed. So rot speed times time dot fixed delta time. Be careful with this one, okay? It's not time dot delta time. This one is time dot fixed delta time, okay? Because we're dealing with rigid bodies. Okay. And we do have an error. The error is rotation speed. We have not defined rotation speed. So we're going to do that now. I'm just going to give you guys some time to finish copying this down.
I have another error.
What's your error?
It under rotation speed. I'm sorry, rotation angle. It says quaternion does not contain the definition for rotation angle.
It's quaternion, and then there's no period in right here. It's quaternion space rotation angle.
Let me look. Yeah, that's what I have.
Okay, can you share your screen?
Okay.
For some reason, rot speed isn't an error for me.
It's not an error. It should be an error. We did it. Oh no. It's rotation speed. It's rot speed, not just speed.
Yeah, I know rot speed isn't underlined. It's not an error.
Okay, well, I'll take a look at it. It's a comma after rotation speed. I'm sorry, transform that rotation.
Oh, right here.
Yeah, it's a comma. Yeah.
Okay, thanks.
So your from is transform that rotation. Your destination is rotation angle.
Okay.
Mhm.
What about this? You did find this.
We haven't defined it. We're going to define it now.
Okay.
Okay, so let's define rotation speed. So let's scroll all the way up to our variables up here, and we're going to make a public float, rot speed, and let's make this equal to 40. Okay. Now that we have this, let's scroll all the way down. So we have we took care of the rotation, and now we need to take care of the movement, because our rotation, it's fixed on, you're now looking at this destination. All we need to do is just move forward. So the car is neatly rotated to where it's supposed to go, and all you have to do is just keep moving forward. Once you move forward and you cross or you pass that threshold of 1 unit, then it's going to change to the next location. Then it's going to do the same thing. It's going to rotate, and then you just have to move forward. So to move forward, we're going to do, we're going to say vector 3, and we're going to call this one direction. And this is going to be equal to transform direction, and we're going to do vector 3 dot up. So whatever vector 3 up is, that means this is forward. We're going to transform it from our end. So that's going to be wherever we're facing, that's our new forward. So that's our direction. We haven't applied our speed yet. So we're going to apply our speed to the next one. We're going to say RB for the rigid body. We add force. We want to add force in direction. And multiply it by speed. And semicolon. Okay, make sure you have this. Save it. Okay. Once you have it, let's go back to Unity. Make sure your path is tagged as path. Once you have that, press play, and your car should be able to move from one point to another.
Wait, mine's tagged as paths with an S.
No, it should be path with no
So
S.
should I change it, or should I change it in the code?
You can just change it in the code as long as it makes sense to you.
Yeah,
but path is just a single path.
I'm just
What's
gonna
up?
probably change it in the code.
I have an error.
What's your error?
For some reason, 90 is underlined as an error for me. Here, should I share my screen?
Yeah. I like how you guys describe your problems. It's like the guy with the hair, with the nose. I'm like,
Wait, what do you mean?
it's very vague. You forgot a minus sign between angle and 90.
Oh, what? It looks like there's not a minus sign.
It's right here.
All right. And then for some reason, rot speed wasn't underlined for me. And also this line right here, line 17 is red.
Okay. So one thing, your your code's pretty funky. So let's erase line number 12, because that's not supposed to be there. Yeah, it has to go all the way to the end. So go all the way to the end. Yeah, and then add it at the end. So press enter, and then add a curly brace. There you go. Now scroll up. Okay. Now it should give you an error with rotation speed. Where's your
It
rotation?
didn't though.
It should give you it.
Mm,
Can you scroll a little bit to the right? Where's your rotation speed?
here, I'll full screen
Oh, it's
this.
okay. Rock speed. Hmm. You should still define rot speed before it.
I can't.
I think when you run into Unity, or when you go into Unity, it's gonna show you that error.
All right, hold on. Let me save this. Let me try.
Nice.
Come on, hurry up. Ah. All right, here we go. Yeah, I got it says random path does not exist in the current context. Hold on, let me go back.
Wait, what's the error?
It says random path does not. Oh, so okay, so I got a bunch.
Okay, just hold on. Um,
Vector.
okay, so first let's start off by adding the rot speed. So let's go to line number 11.
All right.
Oh yeah, misspelling stuff too. Line number 11, and press enter. We're making a new variable. It's going to be a public float called rot speed. Then make it default to 40, equals 40. And for everyone else, you guys can test it out and see if it works.
Yeah, I tested it and it just kind of went.
It works?
No, it just went crazy.
Ah, I see.
Yeah, same with mine. Mine just
Oh
like ran
yeah,
into a wall.
you guys have an animator, so remove the animator.
From which one?
Wait, remove what animator?
Okay. Let's see.
From the enemy car.
Yeah, from the enemy car. Everything looks fine now. Save it and then go back to Unity.
No, for some reason,
Uh.
like my player card went crazy too. I don't even.
Okay, I'll check it out right now. Can you double click the error? What is going on?
This is vector.
Yeah, my car just wants to ram into a wall over and over.
Okay.
It doesn't highlight the line that's wrong. Is the thing.
It's a vector 2. It says vector 2 something is wrong.
What does it say?
Okay, so this one is vector 3. Okay, hold on, go back.
Yeah, sorry.
This is line. Can you change instead of vector 2, it's vector 3 on line 38? Vector 3. Yeah. Same thing with the one all the way at the end. At the end of the line. Vector 3. Yeah. Okay, let's go back and see what's the other problems. Such speed, such wow. What is this?
I'm so confused.
Okay, can you press clear so you can remove all those weird stuff? Okay. Double click on random path, the first one. On line 17.
What is wrong?
Oh, you don't have a random path. Okay, so go after line number 10, press enter.
All right.
You need to get Visual Studios on this computer.
I what?
You should get a Visual Studio on the computer.
This is Visual Studio. It's
Oh,
just
it is?
yeah. It's
Oh.
like it's not dark mode.
Oh, why is it not highlighting you the problem? That's weird.
It defaults to that. I don't know.
Okay, type in int random path. Lowercase
Wait, sorry.
r.
Camel case.
Semicolon. Okay, save it, and let's go back.
All right. All it
Mhm.
is left is rotation angle,
Okay,
current
so
index, vector.
It looks
3.
like you misspelled current index. It says current and
Here, let me just control find that. Here it is.
uh-huh. Double R. Okay, let's go back for another problem.
So many errors. All right. I don't know what that is.
Let's just look at the other one. Rotation angle.
I don't want to find it. There's only one. Right here.
Okay, can you scroll to the right?
Hold on.
Oh, you misspelled rotation. You put rataton.
Rataton.
I think that's what it says. Yeah. Rotation. Yeah. Okay. Looks good.
All right, there we go.
When the last problem.
Let's see. Just vector 3 and possible mistaken empty statement.
I don't know what that is, but let's go to the vector 3. It looks like it's capital V, not lowercase v. There you go. We got it. We have liftoff.
Hey, all right, I'm gonna test this out. Wait, I have to remove the animator, right?
Yeah. So make sure you click on the car and just remove the animator.
All right, let me go do that. Wait, is it the AI car or our car?
AI car. This is all on the AI car.
All right, makes sense.
Let me test mine out.
Should I remove the component or just uncheck it?
Yeah, mine's working. Look at that, guys. Beautiful.
Wait, yours is working?
Yeah.
Mine just only goes forward. So basically, if there's like a wall in front of it, it just runs into the wall.
Okay. So let me help Zane first, right? No. Yeah.
This is Zane speaking.
Yeah. So I'll help you first, and then I'll come to everyone else.
Mine's not even moving.
Yeah, because you have an error. You see at the bottom, it says error.
Oh.
Child out of bounds, something like that. We need to fix that.
All right, whatever. I'll stop sharing my screen.
Yeah.
All right, I'm sharing.
All right, Zane. Let's see what you got.
Basically, all this car does is just go forward wherever it is.
Okay. Can you stop?
Okay.
Can you look at paths? Yeah. Where's path? Let me see path A. Okay, so there's your problem. It can't find the correct path. So
I
this
thought
one
this one
has to be tagged, not that one. That one's just the parent.
Oh, should I untag this?
Yeah. So untag it, and then the other one should be path. That's why I told you it should be path with just no S.
Okay.
Mhm.
It's doing the same thing.
Okay. The next thing is you need to change the rotation speed because I think the rotation speed is pretty slow.
Okay.
Yeah. So make it 250, 240. That works out for me. Wow, that's really slow.
250. Like this
Yeah, and then
All right.
240.
for speed.
Yeah.
That's gonna be like super fast because it's already
Or-
going fast.
Okay,
I don't
fine.
think this is a good speed.
Oh, okay.
Let's see how this works. Whoa. Is that too fast? I think.
Yeah, I guess it looks like it's too fast. Oh, you also have your linear drag is pretty small. My linear drag is 30 and angular drag is 60. None if that helps. 30 and 60.
Try see how that works. See what that does. He's going extremely slowly, I think.
Yeah.
Maybe I probably have to up his speed. I'll try 240. Oh, too much turning.
Yeah, not enough turning, I think. That's weird. Wait, can I see your Oh, you just lagged out. Can I see your what they're supposed to follow? What it's supposed to follow?
Yeah.
The path, I mean.
How do I make him show up?
Just click on the thing and then
It's not showing.
go to gizmos. It's on the right. Yeah, gizmos. No, I'll check it again. Little arrow pointing down, and then uncheck. Oh, you do have it unchecked. Whoa. Oh, that's not good. Can you go to points again? Where's point one? Can you double click
Right
it?
here. Oh, here.
Oh, there it is. Okay,
Oh, now they're all showing up.
that's weird. Okay, can you move your car a little bit backwards?
The blue one?
Yeah,
Like
not
here?
backwards, but yeah, like that. And then
Okay.
can you turn it 90 degrees?
Like that?
Yeah,
Okay.
negative 90, I guess. Okay, now press play and try it out.
Same thing.
It's still going around.
Yeah. It's like it only wants to do the first point.
Uh, can you open up your script again?
Okay.
Okay. Let's scroll down. Okay. So current destination is okay. Can you minimize? Go back to Unity. Yeah. On Unity, if you go all the way to the top right, there next to the lock icon, there's a 3 dots.
Oh yeah.
Click on debug. Okay. Can you scroll down to your script? Okay. So that should give you current. Okay, current. Okay. Can you press play? Press play and then press pause. Okay. Now our current destination is negative 9.63. Let's click on point 1. Yeah. So that is negative.
It's not even the
Nope.
same.
Nope. Let's go to point 2. No. 3. Next one.
It's none of them.
Where is it going then? Okay. Can you do? Can you grab point 1 and then drag it out? Don't parent. No. Remove the parent. Yeah. Just drag it out.
Like into pass, like right here.
No. Out. Like it has no parent. Yeah, like that. Okay. What
Okay.
is position? Negative 9.
Now it's
Is
now.
that correct?
Yeah.
Is that correct?
If you go to the car,
Yeah. Can you go to your car?
it's negative 9.
Negative 9.6 and 3.
Yeah.
That
That what was before?
Yeah.
Yeah, it's the same as this.
Okay. Well, I see another problem. See your z-axis? It's negative 348.
Oh yeah.
So I think that's well. Stop playing. You're not gonna. You can't do changes while you're playing. Yeah. So make sure everything. So that 0 is fine. I think path A has your problem. Yeah, go to normal.
Wait, but they're all the same.
I don't
They're
know.
all 0.
It's the parent. Look at the parent. Look at that parent.
This one.
Yeah, there you go. Because it's
Should I
inheriting.
change this to 0 too?
If you change it to 0, it's gonna offset all your points.
Oh, I don't want that.
Yeah, just keep it
All
like
right,
that.
I think it's fine then.
Yeah, press play.
I think it's working. Wait.
There
let's
you
see.
go.
Yay.
Yay.
Pretty
Just
easy
trying
to
to
beat.
go
I
to.
feel like it's easy to beat because the speed boost don't work for it.
Oh, it doesn't work for that. Yeah.
So it's really easy to beat it.
Yeah. Okay. That's good. So let's move on to the next person. Who else doesn't? It doesn't work. Singer Epic Waffle or Parashar?
It's me.
Okay.
Yeah, I'm
Yeah,
having a lot of
I'm-
problems too.
Yours doesn't.
I quit though.
Yeah. Can you also take a look at your path? Make sure your path, everything is at 0. The Z, sorry, is at 0. That's the problem Zane had.
You
All right,
talking
Okay,
about?
yeah, I look.
Okay. Parashar. I was talking to Parashar. Okay. Can you share your screen?
Yeah.
Please?
Still not sure why it says child out of bounds, but the child is out of bounds. All right. So whenever I try
programming-
playing,
Programming terminology is funny. It's like child out of bounds or masters not detected
this child has no parent.
or child has been destroyed. You're like, yeah. Okay, so is
there's,
it just stuck now?
Yeah, and it says for some reason
Wait,
it's not
where's the
showing.
error? Oh, I think you clicked the little icon for the click on that and it's gonna show up. Okay,
Also, one
yeah.
more problem. Whenever I move forwards, it kind of skews to the left. Like
Oh, yeah. That's a problem with the player controller. Whoa. Yeah, I haven't even fixed that problem yet. We'll take a look at it.
Oh, okay.
Let's not focus on that. Okay, so let's double click on the error. I think I know what your error is.
She's that as a loud car.
Yeah. I hate people. Well, they wake me up, so that's good, but too early. Okay, so your if statement said it's the wrong. You have the wrong symbol. It's greater than or equal to, not greater than minus. 29, line 29.
Oh, that's
No, that was correct.
Yeah.
That's just less than, yeah. That one is not a minus sign, it's an equal sign.
It's just that.
No, there's an equal sign. So greater than equals, yeah. Make sure there's no space between greater than, yeah. And then there you go, perfect. Save it.
Right. Save that bad boy, and then go into this. Come on. All right. Hold on.
See.
All right. There we go. Now it's just not moving at all.
It is moving. It's just going really slow. Change the speed.
Oh, okay.
So click on the green car.
What's the speed?
Scroll down.
It's 250.
Okay. Change your rotation speed to 240.
I just removed the entire component of animator. That's fine, right?
That's fine. Yeah. Yeah. No, that's
Alright.
fine.
All right. Save it.
Also another thing. Can you click on clear on play so it removes the errors so we don't get the no. Clear on play.
Oh.
There you go. Every time you press play, it clears the errors. Okay. Can you click on your path and see if we have that problem that Zane had? Okay, so click on path A. Path A.
There it is.
Yeah, so that one's path. Okay, perfect. And 0, 0. Okay. Go to path.
What'd you say?
Go to the parent path.
Oh, okay.
Okay, that's untagged. That's 0. Okay, everything should work then. Yeah, press play.
I'll try it again. Oh, what? Oh, sorry.
You still have the child out of bounds thing. Okay, let's fix that problem. Let's stop playing. Double click your error. Mm,
It's highlighting float.
no, that's not the problem. Scroll up. It should be right here. What do you have wrong? Hold on. So we have current index plus 1. Oh, you never reset index back to 0.
Oh,
Okay. So you have your if statement. If the path is greater than the child count, okay. Hold on. Let's see. Yeah. So line number 29. So after line 29, you forgot curly braces.
here.
Yeah.
Wait,
An
what
if
do I?
statement. You
What?
require curly braces.
Okay.
Open, close, yeah. Press enter. Inside, we need to do current index equals 0. And yeah, I think that's it.
Now it's moving, but it's acting weird. It's not following the path, and it's brushing up against the wall.
Okay. Let's go back to your code.
All right.
Stop playing. Let's go back to your code.
Oh, I accidentally just started playing again. Right, there we go.
Scroll down. Oh, your problem is line number 37. You have an equal sign instead of a minus sign. 37. Yeah, that should be a minus sign, not an equal. Hold on. Let me check for more errors. Okay, try it out. I don't see any more errors.
Right. Oh, it just disappeared.
No, I think it's going.
Let me see.
It's just really fast. You know you're going backwards, right?
Yeah, I'm trying to find it though. Oh, it just stopped at the starting line.
Oh, do you have a collider there?
I think I do, because whenever I run into this, it stops me.
The finish line?
I don't know if the finish line is like like something on the hierarchies. I don't know.
Yeah, it's right there. It says finish line. It's on the hierarchy. The last one, nice. Undo.
All right.
It's on the hierarchy. The last thing.
Oh yeah, I see it.
Yeah.
I do
Yeah.
have a box collider.
Click on. Yeah. No. Stop. Click on is trigger. Check mark on is trigger. Yeah. There you go. Now it should pass. Yeah. Your card is extremely fast now. Your enemy. So I think you need a. Yeah.
Actually, it's not that fast.
Is it? Okay.
I could probably. I'll slow it down just a bit.
There you go.
Hey, get wrecked. Oh god.
Okay. It looks like it's working. All right. Next.
Thanks.
Yeah. We have Parashar. Did you fix your problem, Parashar?
Yeah, I found a. I mean, okay. So first, one thing that messed up really big for some reason. So my player card, the box collider, got huge for some reason. So I fixed that. That's fine. But now for the enemy card, instead of going like on the points, it tries to go to the walls, and then it bumps into walls.
Okay. Let's take a look at that. Can you share your screen?
Yeah. Okay, so also I have another weird problem
Wow.
with the
It's a lot of
speed
path.
boost.
Okay.
Yeah. No, I don't think I need this. I don't know why. I thought I needed a lot, but I don't know.
It's okay.
Yeah, I can,
Okay.
wait,
We
what?
have path. It's fine. You don't have to erase. Let's that's better.
Yeah.
Okay, let's go to path A, the parent of all the points. So that's tagged as paths with an S. Does that what your script says? If you go back to your script, are you looking for paths with an S or just path?
I'm pretty sure it's path, but it still works somehow.
It shouldn't work. Oh yeah, it's an S. So look for an S. Paths S.
Wait, so is it looking for an S or
No, it's not. It's only
okay?
path. Yeah, change it to an S. No. Just change it in the
Oh,
script. Or
change it in here.
yeah,
Okay.
yeah. Save it. Yeah.
I don't know how it's working then. That's so weird.
Because you have a tag called path, so it doesn't find anything. So technically, our code does, it loops through the stuff, and if it's empty, it loops through empty stuff. So there's no problem.
Oh.
That's yeah. So it technically works. Yeah, it's fine. Okay, go to paths with the S. Yeah, that one.
This is
Okay,
the-
untag. Yeah, untag this one. This one has to be untagged. Yeah, there you go. Okay, try pressing. Okay, we have another problem. Stop. You see the z-axis? It's negative 333, something like that. It should be 0. Yeah, and then check path A, the parent, the child. Okay, and the point should be at 0, right? Yeah.
Yeah.
So. Okay, press play and see if it works.
Yeah, and also this car still does that weird thing.
Yeah.
Okay, so that one just stops.
Okay, I think your rotation speed is pretty slow. Check your rotation speed
Rotation speed for the
for the enemy. The blue car. Yeah. So I have it at 240. So maybe you want to do. Well, okay. You can try out. Yeah, you can try different numbers. And then what about your drag for your rigid body?
Yeah, wait 1 sec. I already started.
Okay.
First. Let me just see if it's a bit better. Yeah, okay, it works good. Actually, looks really smooth.
Okay.
What was the other things? Sorry.
Your drag. Your drag is fine. Linear drag and angular drag. I had angular drag at 60.
Okay.
It's but if you want it at 30, that's fine.
Okay.
Yeah.
Wait, what does this do again? What's the difference?
It limits how much rotation. How much rotation. Like sliding you have. So it adds a lot of friction. So every time you slide, it doesn't allow you. No, every time you turn, sorry, it doesn't allow you
So
to
it's like
slide
a drift kind of.
Yeah. It kind of
Okay.
removes the drift.
Okay, so I don't know if you found the fix for this, the red car yet.
No, you didn't give me the project yesterday. So.
Oh, okay.
Remember, I told you to give me the project at the end.
Sorry. Okay, yeah.
Totally forgot. It's fine. Well, we'll figure it out.
Yeah. Okay.
Okay, so let's get back, everyone. Okay, so now that we have our cars, we can start them at a start line. So if I turn mine on, we can this little things. You guys can have them. If not, then that's fine. You guys can stack your cars here and start your path. And then what I want you guys to do, a challenge, is that you're gonna keep track of how many times the car runs through the laps here. This a finish zone. So you already did this with counting with how many laps you've done. So now instead of this counting how many laps you have done, now you're gonna add 2 more players. They're gonna be exactly the same scripts, except they're gonna have different colors cars. So add 2 more cars. So it's gonna be a total of 4 players. And what's gonna happen is each player is gonna keep track of how many laps has happened. And then once it reaches, let's just say, to the 5th lap, that car shuts down and it's not going to move anymore because it's done. It's game over for it. We're not going to keep track of ranking yet. We just want to keep track of how many laps that car has done. So yeah, I think you guys can do it, right? Yes. Did you guys understand it, or did you guys understand the task, or
just make more cars, right? And then
make more cars, and then
I'm a little confused by it.
Okay, so make more cars, and then what you have to do is each car has to keep track of how many laps it's done. Once it's done 5 laps, it's just going to stop. The car's just gonna stop moving. So you need to access the movement script or the car AI, and it's gonna set speed to 0.
How many cars should we make?
Add 2 more cars, so total of 3 enemy, and you is 1. You are 1. So total of 4 cars.
What, do we have to make new scripts, or can we just use ones we already have?
Yeah, no. That's what I just said. You can use what you have. You don't have to make new scripts. Yeah, just make sure. I think just keeping track of the how many laps you've done. I think that one has to. You have to make a new script for that because this finish line only keeps track of the players. Or no, never mind. You can do it. You just have to you just have to tag each one. Then you could say car 1, car 2, or computer player 1, 2, and then just have an if statement saying if computer player has crossed, then add plus or plus to whatever value. Anyway, you guys can figure it out. There's various ways of doing it. You guys can figure it out. Okay, so I'll give you guys 10 minutes. And I guess we'll present at the end.
Fernando,
Mhm.
can we see the animation thing again? I don't know if there's like a weird problem because in the animator it like looks really weird. I don't know if it's correct.
Sure. Let me take a look.
Is this right?
No. You should only
Yeah.
have one blend tree. So just delete all your other animations and just have one blend tree.
Wait, delete all of this?
Yeah. Those are animation states. Yeah.
Okay.
Yeah.
Just
Okay.
go like that.
Go inside the blend tree. And yeah, that's what you have. Yeah, that should be fine.
Oh, it started working. Okay.
Was
That
that your
was it.
problem?
Yeah, that was the problem the whole time.
Damn it, dude.
That's
Okay.
so stupid. Okay. Thank you though. Okay, that took
Okay.
a while.
I
Okay.
see. Yeah, the only problem is when you let go, it defaults to like a weird position.
Yeah.
So that again, that's something I haven't done yet. I'll fix it later.
Okay, I gotta get rid of the speed boost. Holy.
Yeah, too much speed. Anyways, okay, so work on the finish line stuff and keep track of.
Yeah.
So a total of 4 players.
Yeah.
Give you guys 10 minutes.
Do I have to assign a car to a specific path? I'm assuming I do, right?
You can make different paths, or you can just have one single path. If you
Oh.
have one single path, everyone's gonna bunch into one line. That'd be weird.
For some reason, I think both cars are following both paths.
Yeah, that can happen. Reason why, because it's choosing randomly.
Oh, okay.
So there's a possibility that two cars can follow one road.
Fernando, I have a question.
What's up?
I need help with something.
Sure.
Okay. Should I present or?
Yeah.
Okay. All right. Can you see?
Yeah.
So I'm trying to like set the speed to 0, but I'm not sure how. So I just did like find object with tag car1, and I just like tagged all my cars.
Okay.
And I'm trying,
Yeah.
but it's not working.
So you're getting a game object with tag. That's good. But you're just getting that component game object. Or where's speed?
Well, oh shoot. Under like each of these cars, there's speed right here.
Yeah, but what component? What is it called?
Car AI. But I
Yeah,
tried
so
looking up car AI, I couldn't find it.
Yeah, we need to get the component car AI.
Oh, okay.
So right after you find the object, you dot get component.
Alright, let's get rid of this.
Mhm.
Get
component. Uh-huh.
car AI.
Mm-hmm.
Dot speed.
Open close parentheses. Open close parentheses. Mm-hmm. There you go.
Speed. Alright, just like that?
Yep.
Okay. Alright, I think that fixed it. Hopefully if I did everything right, it should work.
Yeah, hopefully.
I'm just gonna, I guess, wait and see if they stop.
I'm still not exactly sure how I could make it so they know that there's 5 laps. What script would I put that in?
You could write it in your finish line script.
Oh, all right.
Oh, I think it worked because I think these guys just hit 5 because they randomly stopped. See if this one stops too. I didn't. That's weird. Okay, I think they just hit 5, so they stopped.
Yeah, I think the problem that you had was these cars went slow, or I think they turned around a couple of times. So I think
Wait, me or him?
No, the red and green car.
Oh.
So I think they went around a couple of times. So that's why they crossed the finish line. Technically, crossed the finish line a couple of times before the black car.
Oh. Because they started on it?
No. It's they were on it, but then each one pushed each other out. So then they spun out of control. So they went back to go to the point, and they came forward. So that counts as 2.
So they kind of cheated the system.
Yeah.
Yeah, because if I just went like back and forth like this a bunch of times, I keep getting laps.
Yeah, it's the same with you. You have 23 laps, even though you complete only 1.
Yeah.
Mhm.
Anyway, I think it works though. So
Alright.
I'm gonna split them
All
apart.
right, so we have 2 more minutes left.
Oh, Fernando, I have like another thing. For some reason, they're going the wrong way.
Nope, they're going the right way.
No, they are right now, but like at the beginning, they always go the wrong way.
Yeah, because look at where the first point is and
Oh,
where they're starting. They're
well, what do I
program.
do?
They're programming to they're doing their program to
Oh,
fix that problem. Just move the point one in
okay.
front, or hold on, or
Just delete it.
no, just you could just change the position of point one and point 6.
Oh, yeah, I could.
So just actually hold on. Well, what's the next thing? Point 2. Okay, so just put point 1 at the end after point 6 on the hierarchy.
Like just like right here.
Yeah, right there. Because the first point now is point 2, and point 2 is the closest to them.
Okay. There we go.
Okay, perfect. So I just finished my waffle. Good. All right. So Yuri showed your stuff. Anyone else wants to show what they done? It's fine if you. It's fine if you didn't complete it. I just want to see. Yeah, you trying.
Mine has like I got all the cars to work the way that I wanted them to, but I don't know how to do the laps thing.
No, that's fine. First, let's take a look at the Mr. Waffle.
All right. So I'm kind of the same as what was I gonna say? Never mind. But yeah, all the cars work. For some reason, the motorcycle just shoots off and lands here. I'm not exactly sure why. I think the path's fine. I just don't know why it is that. But yeah, all the other cars work pretty well. It's just that I wasn't sure how to do the lap script, so
Okay.
it looks real. It's really bad. Like I wasn't sure how to do it. So and I didn't want to copy from the internet. So I just went into the game manager script and I did like this. I like on trigger enter, and then I set up so like like when you pass through it, I guess what I was trying to do is when you like when it collides, then it adds 1 point to the score, and then when the score equals 5, then the speed is set to 0. But I don't really know how to execute that, so that it ended up just like I don't know, tons of errors.
Hey, well, one thing. Remember, for every car that's passing by, you need to keep track of that car's value. So if you have 3 racers, then you need to have how many variables?
3. You
Yeah.
need to have 3.
So car 1 lap, car 2 lap, car 3 laps, and then those slowly increment based on how many times they cross the finish line. Okay, that's fine. That's fine. You don't have to write it now. I'll show you the solution later. All right.
Wait, but do you know why the motorcycle would just shoot off like and run into the thing?
Okay, let's take a look at it. Click on the motorcycle.
Alright. Hold on. Alright. Here it is. The speed is actually 180, so it should be slow, but it like shoots off.
Try changing the linear drag and angular drag.
Oh, that's what that is. I forgot to set that. Probably what it is.
Okay.
It's just sliding.
And also gravity scale is 1.
Oh, alright. The gravity scale is 1.
0.
Oh, 0.
Yeah. Remember, no gravity.
I'll change this to 0. Change this. Alright, that's good.
You accidentally checked mark used by effector. Can you change that? I'll check it. Yeah.
Alright. This should work now. The motorcycle's super slow, but whatever.
Okay. Looks like it's working, right?
Yeah. Alright, thank you.
Okay. All right. Parshar, let's see what you have.
Yeah, I'll present.
Well.
Hey, can you see it?
Yeah.
So I have all of this.
Okay. Your cars are working.
Yeah, they work fine. I don't know
Wow,
why
it's
they're
pretty
so
good.
slow now, though. I don't know what happened.
Okay. Good. And did you do anything with the laps?
No, I didn't get to that. I mean, I was.
Did you create the script yet, or no?
No, I was so focused on the paths.
Okay, that's fine. Okay, so let's have Zane show his project, and he's gonna explain how he did the detection for the finish line.
Oh, you want me to explain?
Yeah.
Okay. So, basically, I just went into the game manager script because
you're not sharing your screen.
Oh. All right. So basically, I went to the game manager script, created a few more variables for the different cars. Then I went down to here, the on trigger enter, and then I just added 3 more if statements for the new cars. And then I just checked the collision tag and checked if it was the tags that I put on the cars. So I put the tags as car 1, car 2, and car 3. And then in this, I add 1 to the laps. And then here I do another if, which is if car 1 laps are greater than or equal to 5, so it's like gone around 5 times, then it's going to find the object with tag. So it's going to find car 1, and it's going to go to the car AI component, and it's going to change its speed to 0. And I just did that 3 times. Yeah, that's all it really did.
Yeah, that actually makes a lot of sense.
Yeah.
Yeah, that I don't know why I didn't type that. It's a lot better than mine.
Yeah, so that looks really good. Thank you, Zane. Yeah. So that's actually the solution. There is another solution where each car has their own script. Usually, I'm not gonna say that's a little better. But if you want more control on the car, let's just say you want the car to handle. Let's just say you put items and you can smash the other cars and they take lives. I mean, they take health and once it's kind of like what is that movie called when the cars race against each other? Death Race, I think.
Fast and the Furious?
Is it Fast and the Furious? But they destroy cars while they're racing with
Mad
machine guns and
Max?
stuff.
I don't know.
No, that's Death Race, I think.
Yeah, so you have like other things and other cars can punch other cars. Well, I'm just saying if we're doing something like that, then each one would have their own property, right? But now since our game is pretty simple, then what Zayd made with the race, the finish line taking care of that, the game manager, that's totally fine. It works out.
I have a question.
Yeah.
So how would you make it so that you could randomize the path for all of them?
So the paths are already randomized. So if you look here on car AI, we have here we have find the path or game object with path. What you can do is you can actually have this inside here this if statement. Whatever. The only thing is that each path has to have the same amount of nodes in order for this to work. So what's going to happen here is for each node is actually going to change to a random node. So the car is going to go to path 1, maybe going to go to path 2, path 2,
Okay.
path 1.
Yeah.
Then it's going to be always random. So it's going to look something like this. So if I move this here where it says here current destination. Oh, I got it wrong. So copy this, then put it down here where we have current destination before current destination, and that is going to completely randomize where the car is going to go. The only thing is you need to have the same amount of nodes for each path.
Okay.
Or else you'll run into an error.
Also, how would you? So, this is like a question to everyone. Did you guys make different scripts for all of the cars? Because that's what I did, and then I just changed the tags.
I didn't.
Okay. Because I just made another script for all of the cars and then changed the tag for the different paths. But that's fine, right?
Why are you changing tags for the path?
No. So I made so I assigned a path to all of so I made another. So I have 2 enemy cars basically.
Mm-hmm.
So I made 2 scripts and I just copy pasted them. The one from the first one. And and then I changed the find game object with tag paths. I changed it to paths B for the second card that I made. How would you make it into like one script?
Can you show me what you're doing?
Yeah, okay.
I can't visualize it.
Okay, so basically, so I first the first car A that the car AI that we made was right
Mhm.
here. Then I just copy pasted that into this, and I changed the class name and everything. Then I made this paths B instead of just paths. And then here I have two paths. One is paths, and then the other is just paths B. That's how I
Oh,
did it.
okay. Okay, so you're doing is so you're skipping. Wait, go back to the script. I think you're still doing random stuff though.
I'm pretty sure I am. But
Yeah, yeah,
that's
yeah.
just how I did it.
So what you're doing, that's fine. So what you're doing is you're finding paths. Even though you're looking for a list of paths, you're still looking for one path.
Yeah,
And you're assigning only that path to that
each car.
car.
Yeah.
Yeah, so it wouldn't be repetitive. Okay, so the thing you can do is you can have a variable. Well, you only need one script. You don't. So the thing you copy and paste the car AI 1, 2, 3. You don't need them. You just need car AI, the first one.
Uh-huh.
And what you can do is you can keep track of. You can have the game manager. You can have a script on the game manager that's going to keep track of all the cars and then what is their path. If two paths are the same, then it's going to choose again, and then until it has all of them have different paths. Is that what you're looking for?
Yeah, but honestly, I had no idea how to do that, so I just did it like this.
Okay, yeah, but that's how you go. You would do it. You would have the game manager kind of keep track of where what distance what path did they choose,
Yeah,
and
okay.
then if one of them has the same path as the other, it's just gonna choose another random path.
Uh-huh.
Or you can just increment instead of you can have all the paths and you can say, okay, this one is 0, this one is 1, this one is 2. So it's not random. It's just each one now it has their own path.
Yeah, okay.
But that makes them predictable. So I don't like predictability. There you go.
Okay.
Okay. All right. So I think that's it for today, guys. That's all I had for today. Unless you guys want to do something else in the next 15 minutes.
Are we gonna do some multiplayer stuff next class?
Yeah, next class
Yeah.
next class we'll try to fix the this weird player movement. It should take maybe like 20 minutes. Then we'll
Okay.
start making some multiplayer stuff.
Okay.
All right.
Multiplayer.
Thank you.
All right. So if there's no questions, thank you guys, and we'll see
Thank
you guys
you.
next week.
Yeah,
Bye.
thank you.